Ionization potential. Ionization potential. This was another important periodic property that was exhibited by elements arranged in the periodic table. Ionization potential is the amount of energy that required to remove a loosely bound electron from an isolated gaseous neutral atom is known as ionization potential. What is ionization potential? The amount of energy that required to remove an electron from an isolated neutral gaseous atom which was bounded with a weak nuclear attraction is known as ionization potential. Ionization potential is the amount of energy that required to remove a loosely bound electron that was present in the outermost energy level of an isolated neutral gaseous atom is known as ionization potential. This ionization potential can be expressed in terms of ergs per atom or joules per atom or kilocalories per mole or in electron volt per atom also. The amount of energy that required to remove a loosely bound electron from an isolated neutral gaseous atom is known as ionization potential. What is a loosely bound electron? Loosely bound electron means an electron which is a weak nuclear attraction in an atom. In any atom, naturally, the electron which is present at the outermost energy level of an atom is naturally will have less nuclear charge. So, we can claim it as a loosely bound electron. So, to remove that electron, we have to supply some energy. So, the removal of electron from an atom is an endo-energetic reaction. And a certain amount of energy is required to remove that electron. What happens when an atom loses an electron? For example, let us take a metal atom. Generally, metal atoms will lose electrons. So, when a metal atom is in a gaseous state, an isolated state in an atom. So, when this gaseous atom, if we take one electron, it forms its ion, that is positive ion, and one electron is removed. Now, why this positive charge that exists on this ion or on this atom, and we call it as an ion? Here M is found to be neutral, but here M plus, this M is found to be a positive ion. It indicates that atoms are having equal magnitude of oppositely charged species in it. That's why they appear in neutral. Now, why the positive charge is arised? We know that in any atom we have protons and neutrons. So, the number of protons are equal to the number of electrons that are present in an atom. Of course, number of neutrons may vary, but the number of electrons and the number of protons are same for any atom, then it is equal to its atomic number. For example, if you take sodium atom nucleus consisting of 11 protons, that means 11 positive charges in its nucleus. There are 11 positive charges present in the nucleus. That is, 11 protons are present in the nucleus of sodium atom. Outside its nucleus, in first energy level, we have 2 electrons. In second energy level, we have 8 electrons. In third energy level, we have 1 electron. This is the condition that was present in the sodium atom. First energy level we have 2 electrons, in second energy level we have 8 electrons, and in third energy level we have 1 electron. Now, in any atom, if 8 electrons are present in its valency shell, that is the last energy level, then the atom has more stability than the other atoms. So, each and every atom try to acquire that 8 electron configuration. We call it as octet electronic configuration. So, here also sodium has tendency to get that 8 electron electronic configuration. So, here in the valency shell only 1 electron is there, but in n-1 shell, that we call it as the penultimate shell. In that shell we have 8 electrons. That is why sodium has tendency to get that 8 electron configuration. So, the way how sodium will get that 8 electronic configuration, simply by losing this electron. What happens when it loses this electron? Now, the second energy level will become the valency shell. Automatically, after losing that electron, the second energy level of sodium will become valency shell, which contains 8 electrons. Now, in this situation, what is the exact position? 11 protons are present in its nucleus, but outside nucleus we have 10 electrons. 11 positive charges are there, but only 10 negative charges are present, so that 1 unit positive charge will exist on it. That is why sodium, when loses 1 electron, it was converted into a unipositive ion. Na gives Na plus 1 E minus. In this process, sodium will absorb certain amount of energy. The amount of energy that was absorbed by sodium atom to convert into sodium ion, or the amount of energy that was absorbed to remove the last electron of sodium, is said to be ionization potential. The amount of energy that was absorbed during the removal of last electron in a sodium is said to be ionization potential of sodium. We know that in discharge tube experiment, what we will do? You will take a discharge tube, and here 2 electrodes are arranged at the both sides of the discharge tube, and here the whole air present in it will be removed by vacuum pump, and at low pressures, nearly 0.01 mm Hg pressures, sodium vapors were filled in it. When sodium vapors are filled and certain voltage was applied, high voltage and low pressure, then at a fixed voltage, at a given voltage or a certain amount of voltage, suddenly one glow will form in between these 2 electrodes. That glow is nothing but the electrons that was released. The value where that electrons, that glow was started, that indicates the ionization, first ionization potential. If you go on increasing, in some other level, again the glow was, brightness of the glow was increased. that indicates the release of second electron from the same atom. That value is said to be second ionization potential. So, with the help of this discharge tube experiments, we can calculate these ionization potential values, and they can be expressed in electron volt per atom, joule per atom, or ergs per atom, or kilocalories per mole. This is the way to calculate the amount of energy. That means at that voltage these atoms are ionized. In first ionization, that we call it the first ionization potential. If its glow was increased, then it's said to be second ionization potential, and after some time a third ionization potential will arise. Now here sodium has only one electron in its valency shell. After losing that electron, sodium electronic configuration will be equal to neon's electronic configuration. In such cases, sodium has no tendency to lose another electrons. That's why sodium cannot form Na+2 ion, because the second ionization potential of sodium is very high. Where is the case of magnesium? In magnesium, the nucleus of magnesium contains 12 protons in its nucleus, 12 positive charges in its nucleus. Outside nucleus, in first energy level we have 2 electrons, in second energy level we have 8 electrons, and in third energy level again we have 2 electrons. This is the electronic configuration of magnesium. Now magnesium has tendency to lose these 2 electrons, because it can get that 8 electron configuration after losing 2 electrons only. That's why if you take magnesium like that, in the discharge tube, the vapors of magnesium at low pressures and voltage was applied. Now then, magnesium, by absorbing some certain amount of energy, which we call as IP1, it was converted as Mg plus 1 E minus. Now this magnesium ion by accepting some more energy, which we called as a second ionization potential, then it converted as Mg plus 2. So during the formation of Mg plus 2 from Mg, in 2 stages it loses 2 electrons. So the number of positive charges that were present on an ion are equal to the number of electrons that was removed during the formation of that ion from its atom. Not only in magnesium, in any atom, the number of positive charges, that means we should not call it as an atom. When it has a charge, we call it as an ion. So the number of charges, positive charges, the number of positive charges that were present on an ion are equal to the number of electrons that were lost by that atom during the formation of that ion. The number of electrons that were lost by that atom during the formation of that ion is said to be ionization, is equal to the number of electrons that were lost by that atom during the formation of that ion. So this number of electrons is generally equal to the number of electrons that were present in its valency shell, because automatically its penultimate shell will have 8 electrons. So if you take aluminum, in the valency shell you have 3 electrons. By losing 3 electrons, aluminum will get or to form Al plus 3 ion. For example, Al. First it loses 1 electron. The energy that remove that 1 electron, first electron, is said to be first ionization potential, and from this again you have to give some more energy, which we call it as IP2, to convert it into Al plus 2 plus 1E minus, and again some more energy is required, which we call as Al IP3 to form Al plus 3. So here, in a sequence, aluminum is losing one electron, second electron, and third electron, so that it forms Al plus 3. So the energy that absorbed during the removal of first electron is said to be IP1, first ionization potential. In the second electron is said to be IP2, that is second ionization potential, and this is third ionization potential. For any atom, whatever the atom it may be, the first ionization potential, IP1, is less than IP2, is further less than IP3. IP1 is always less than IP2. Why? In a neutral atom, nuclear attraction over the valency electron is comparatively less with the nuclear attraction that was present in a unipositive ion, because after losing one electron, the total negative charge outside the nucleus is smaller than the total positive charge that was present in the nucleus. Because of this higher nuclear charge, these residual electrons will have higher nuclear attraction over the valency electron. Such why it is difficult to remove such electrons. That's why the second ionization potential of an atom is always greater than first ionization potential, and third ionization potential is furthermore greater than second ionization potential. This is due to the increasing of nuclear charge on the residual electrons. So ionization potential. Ionization potential is the amount of energy, that is the minimum amount of energy that required to remove a loosely bound electron from an isolated neutral gaseous atom is known as ionization potential. This ionization potential is measured in electron volts per atom, or ergs per atom, or joules per atom, or kilocalories per mole. These are the units to express ionization potential. So why atoms will lose energy? They will lose electrons. Atoms will lose electrons to get the stable electronic configuration. Those atoms which are not having 8 electrons in the valency shell, and which are having only 1 or 2 or 3 electrons in their valency shell, and containing 8 electrons in its penultimate shell, to get that stable inert gas configuration, these elements has tendency to lose electrons, but they cannot lose electrons on their own. It requires certain amount of energy to remove such electrons. So that amount of energy which is required to remove a loosely bound electrons that are present in the outermost energy level of an atom is said to be ionization potential. So the amount of energy that was used in the removal of first electron is said to be first ionization potential. Second electron is said to be second ionization potential. Third electron is said to be third ionization potential, and so on. And by losing of electrons, these atoms will convert it into positive ions. If it loses one electron, a 1 unit positive charged ion will be formed, that is +1 charged ion is formed. If it loses 2 electrons, +2 charged ions are formed. If it loses 3 electrons, +3 charged ions will be formed. So the number of positive charges that exist on an ion are equal to the number of electrons that were removed from that atom during the formation of that ion. Suppose, for example, Al plus 3 ion is there. So Al plus 3 ion is formed by removal of 3 electrons from Al atom. Mg plus 2 ion is formed by removal of 2 electrons from magnesium atom. Na plus ion is formed by removal of 1 electron from sodium atom. So the number of charges that exist on an ion are equal to the number of electrons that were lost by that atom during the formation of that ion. Now let us observe the influencing factors which influence the amount of this ionization potential. The important factors which influence this ionization potential are factors that influence the ionization potential. Factors that influence the ionization potential. The important factors that influence the ionization potential are, first one is atomic size. Second one is nuclear charge. Third one is screening effect. Fourth one is penetrating power. Fifth one is electronic configuration. These are the 5 important factors which influence the magnitude of ionization potential. Whether the ionization potential of an atom should be more or less is influenced by these factors: atomic size, nuclear charge, shielding effect or screening effect, penetrating power, and electronic configuration. Atomic size. So what is the influence of atomic size? When the size of atom is increasing, the distance between the nucleus and lost electron will go on increasing. If size is this, this is the distance. If size is this, this is the distance. If size is this, this is the distance. So if the size of the atom or the radius of the atom is increasing, the distance between the nucleus and valency electron increases. What happens? Nuclear attraction over the valency electron decreases. When size of the atom increases, the distance between the nucleus and lost electron increases. When the distance between the nucleus and lost electron is increasing, nuclear attraction over that electron will also automatically decreases. So it is easy to remove such electrons. So for such atoms which are having larger atomic sizes, ionization potential values are very low. So as atomic size is increasing, ionization potential value decreases. What is the first factor? The first factor which influences the ionization potential is atomic size. Generally, the distance between the nucleus and lost electron is considered as radius of the atom. The size of the atom will depend upon the radius of the atom. So when atomic size is increasing, it is nothing but the increase of distance between the nucleus and the lost electron. When the distance between the nucleus and lost electron is increasing, nuclear attraction over that electron will also decreases. It is increasing, nuclear attraction will decreases. When nuclear attraction is less, such electrons can easily be removed. So the second influencing factor is nuclear charge. Nuclear charge is dependent upon the number of protons that are present in the nucleus, because protons are the positively charged particles in the nucleus. So As nuclear, the number of protons present in the nucleus is increasing. The positive charge in the nucleus will increases. When positive charge increases, automatically the nuclear attraction over the valence electrons that were present in outside the nucleus will increases, not only in valence electrons. The nuclear attraction is present in all electrons. But comparatively, valence electrons will have less nuclear attraction. So, when nuclear charge is increasing, nuclear attraction over the valence electrons will also increases. In such cases, we require to influence or use more energy to remove such electrons. So, as nuclear charge is increasing, ionization potential value will also increases, provided when atomic size is not increasing. Suppose if nuclear charge is increasing, atomic size is also increasing. So, because of the increasing of this nuclear charge may not have effect on the electrons when they are far away from the nucleus. This comparison is only for the electrons which are present in the same distance. At the same distance, electrons are presenting and nuclear charge is increasing. In such cases, ionization potential value will gradually increase. So, after removal of one or two electrons from the atom, effective nuclear charge, we call it as that is charge, nuclear charge of positive ions, we call it as a net charge or effective nuclear charge after removal of one or two electrons. In such cases, nucleus will have more attraction on the residual electrons. In such cases, it is very difficult task to remove those electrons. So, as nuclear charge is increasing, ionization potential will also increases. As nuclear charge increases, ionization potential will also increases. Once again, nuclear charge. Nuclear charge will depend upon number of protons that are present in the nucleus. As number of protons are increasing, the nuclear charge, total positive charge of nucleus is increasing. When total positive charge of nucleus is increasing, it will have more attraction on negatively charged electrons. So, automatically nuclear attraction over the electrons will increases. When nuclear attraction over the electrons are increasing, to remove such strongly attracted electrons, it requires to use more energy. That means, as nuclear charge is increasing, the amount of energy that required to remove that electrons should also be increased. So, as nuclear charge increasing, ionization potential value will also increases. So, it is difficult to remove an electron from a positive ion than a neutral atom, because in a positive ion, nuclear attraction is comparatively less than the neutral atom. As positive charge increases, nuclear charge over the valence electrons are also increases. That is why, as positive charge increases, ionization potential values will also increases. And third one is shielding effect. What is shielding effect? The electrons which are present in between the nucleus and valency electron. This is the valence electrons. Here we have some other energy levels. For example, this is the nucleus. This is one energy level, second energy level, third energy level, fourth energy level. So, if electron is present here, if electrons present in this inner shells are increasing, as the number of electrons in the inner shells are increasing, these electrons will shield the nuclear attraction on the valency electron. Because of this, nuclear attraction over the electron decreases. This effect is called as a shielding effect. What is shielding effect? The electrons which are present in between the nucleus and valency electrons are increasing, these electrons which are present in between the nucleus and valency electron acts as screens and prevent the nuclear attraction over the valency electron. So the prevention of nuclear attraction over the valence electron by the electrons present in the inner shells is known as screening effect or shielding effect. Screening effect or shielding effect. The electrons that are present in between the nucleus and valency electron acts as screens and shield the nuclear attraction over the valency electron. This effect is called as shielding effect or screening effect. As this effect increases, nuclear attraction over the valency electron will decrease. When it decreases, it is easy for us to remove such electrons. So as shielding effect is increasing, ionization potential value of electrons, of atoms will also decreases. Shielding effect or screening effect. The electrons which are present in between the nucleus and valency electron acts as screens and shields the nuclear attraction over the valency electrons, and it decreases the nuclear attraction over the valency electron. This phenomena is called as shielding effect or screening effect. Shielding effect or because of the screening effect. As electrons in between the nucleus and valence electrons are increasing, ionization potential value will decrease. We can observe this effect in the fourth period elements. In fourth period elements, the first element is potassium, where it has 4s1 electronic configuration. The second electron is calcium with 4s2. Then the third element, scandium onwards, electron will enter into 3d orbital. Gradually from scandium to zinc, the electrons are enter into the third energy level. But valence electrons are present in the fourth energy level. Here, because increasing of atomic number, nuclear charge is increasing. But these electrons which are present in between the nucleus and valency electrons will act as screens and decreases the nuclear attraction. That's why, though the nuclear charge is increasing in the nucleus, nuclear attraction over the valence electrons will not increase. Because of that, the ionization potential values of these transitional elements are almost equal. They will not increase according to the increasing of atomic number in second and third period elements. As atomic number is increasing, ionization potential values will also gradually increases. But that type of increase we will not observe in the case of these transitional elements where these electrons are enter into inner shells, which creates that shielding effect. So what is shielding effect? The electrons which are present in between the nucleus and valency electron shields the nuclear attraction over the valency electron. This effect is said to be shielding effect. Next, the fourth one is penetrating power. Penetrating power means penetration of electrons towards nucleus. Penetrating power means penetration of electrons towards nucleus. For example, in a given energy level, for suppose let us take fourth energy level. In fourth energy level, the electrons present in the f orbital will revolve around the nucleus in a circular path. In 4d, electrons revolve around the nucleus in elliptical path. In 4p, further ellipticity. In 4s, it is. This is 4s, this is 4p, this is 4d, and this is 4f. So the penetration of 4s electrons is more than 4p, is more than 4d, is more than 4f. The penetration of s electrons present in the fourth energy level is more than 4p, is more than 4d, is more than 4f. So the penetration of 4f is greater than 4p, is greater than 4d, is greater than 4f. So as the penetration of electrons, 4s electrons is known more, it is more closely to the nucleus than p, than d, than f. Even if you observe the shape of these orbitals, s orbital is in spherical shape, and whereas p orbital and d orbital, they are dumbbell and double dumbbell and so on. Naturally, the penetrating power, the 4s electrons are more closer to the nucleus than p, than d, than f. So it is difficult to remove 4s s electrons than f electrons present in the given main energy level. That's we call it as the penetration power. Now, the fifth influencing factor is electronic configuration. Electronic configuration. We know that when degenerated orbitals are available, for example, 3p orbitals, 5d orbitals, and 7f orbitals, we call them as a degenerated orbital. The orbitals having same energy are said to be degenerated orbitals. When electrons are entering into the degenerated orbitals, the pairing of electron is possible only when all orbitals are filled with one electron each. The pairing of electron is possible when all degenerated orbitals are filled with one electron each. So those atoms which are having this half filled configuration, that is one filled with one electron each, or full filled configuration, two electrons each, will have more stability than the other ions, which are having this type of stable configuration, fulfilled with two electrons each. Suppose p orbital fulfilled with two electrons each, or half filled with one electron each, will have more stability than the nearby atoms. So such atoms ionization potential, for such atoms removal of electron is difficult task. So in such atoms the ionization potential values will be more. So these are the 5 influencing factors. One is atomic size. As size of the atom increases, the distance between the nucleus and valence electrons is increasing. When the distance increases, automatically nuclear attraction over the valence electron increases. In such cases, ionization potential will decreases. That is, as atomic size increases, ionization potential decreases. Second one, nuclear charge. As charge in the positive charge in the nucleus is increasing, the electrons which are present at the same distance will have more attraction. So such high nuclear attraction is there, it is difficult to remove such electrons. So as nuclear charge is increasing, ionization potential will also increases. And third one is shielding effect or screening effect. The electrons which are present in between the nucleus and valence electrons acts as screens and shield the nuclear attraction over the valency electrons. As the number of electrons present in between the nucleus and valence electrons are increasing, the nuclear attraction over the valence electron decreases. In such cases, it is difficult to remove those valence electrons. Sorry, in such cases, nuclear attraction over the valence electron will decreases. So as shielding effect increases, ionization potential value decreases. Then penetrating power. The penetrating power of electrons present in different atomic orbitals are S is greater than P is greater than D is greater than F. That means electrons present in the S subenergy level are more closely to the nucleus than P, than D, than F. That's why in a given main energy level, it is difficult to remove S electrons than F electrons. And fifth one is electronic configuration. The elements which are having half filled stability or full filled stability, that is when degenerated orbitals are half filled with 1 electron each or full filled with 2 electrons each, will have more stability than the other elements. So such atoms which are having that half filled stability and full filled stability will have more IP values than the rest of the elements. So these are the influencing factors which influence the ionization potential. Now let us observe its periodicity. Periodicity means the change of ionization potential along the period and along the group is known as periodicity. So in a period from left to right, as atomic number is increasing, we know that atomic size is gradually decreases. In a period from left to right, as atomic number is increasing, atomic size is decreases. When atomic size is decreasing, nuclear charge over the valence electron will increases. That's why ionization potential will increases. So in a period from left to right,